In this question, this is a train which is moving towards an observer which is at rest, but the speed of the train is slowing down. So it was producing the sound of a constant frequency and intensity. That is, this sound is traveling in this direction. So it has a speed v that is equals to f lambda. F is a frequency. But for an observer, from the perspective of an observer, this is a source which is coming towards an observer. So observer is receiving more energy per unit time. So this wave will be contracted for an observer. So if the observer observes the frequency, this thing, and this is the intensity of the observer, so in this question you have to find out what will be the effect on both of these quantities if this source is slowing down. And why we have shown this contracted wavelengths, because you know that when the source moves towards observer, these wavefronts are compressed on the one end, which means like this, and the distance between any two wavefronts is equals to wavelength, so which you see that as decreases. Observer's intensity is the energy received by the train per second and per unit area. That is basically the formula of the intensity, which is basically the power divided by area. So as the train is moving towards an observer, more and more energy is received by the observer in every second. So we can conclude about that the intensity is increasing. But what about the frequency? As it is slowing down, you must take this thing in account. So whenever the source moves towards an observer like this, f prime is equals to v over v is the speed of sound, v minus us is the speed of source into f. So this f is the actual frequency of the sound that is produced by the horn, and f prime is the perceived frequency, the number of vibrations perceived by or the received by an observer in every second. Now we must remember that this us is decreasing. So if us speed of source is decreasing, which means that the denominator, which is v minus us, must be increasing. Well, you can take example. Let's say if the source speed was 10 meter per second, and then it became v over v minus 5 meter per second, and then it decreased to v minus 2. So as you see, the denominator is increasing, v minus 10 to v minus 5, then to v minus 2. So when the denominator is increasing, so this factor v over v minus us is decreasing, and it is becoming smaller. And when it is becoming smaller, because this factor is multiplied with the actual frequency, so when it is becoming smaller, so then f prime must be less than the actual frequency, so we can say it is decreasing. So option D is the right answer. Observer's intensity is increasing, but the frequency received by an observer is decreasing.